today we are going to be talking about how we can prove triangles are similar by AA or angle-angle similarity. So just that they're similar, not necessarily congruent. That's important to remember. So we're going to start off reviewing a couple things that we already know from previous lessons. First, it says the sum of three angles in a triangle is blank. Well, we all know that the sum of the angles in a triangle is 180 degrees. If two angles in a triangle are congruent to two angles in another triangle, then the third angles in both angles must also be congruent. We talked about this idea back in 4.3 Day 2 notes, saying that if we have two triangles, so maybe something like this, and we are told that these two are the same and that these two are the same. So I'm giving actual values here, but even if they didn't give actual values, if we only knew they were the same, we know that whatever these two are, whenever you add them up and subtract them from 180, it's going to leave the same amount of degrees for this angle as it would for this angle. For this specific one, we're able to add 90 and 40, subtract from 180, and see that there must be 50 degrees left for the missing angle. So, as long as you know you have two angles in two sets of triangles that are congruent, you must also know that the third angle is congruent, and therefore your triangles are going to be similar. Okay, so that leads us into this similarity postulate. If we know that two of our angles are one triangle are congruent, to two angles in another triangle, then we automatically know that third angle must also be congruent, and therefore our two triangles are similar. So remember the difference between similar and congruent. Similar means that it looks the same but could be smaller or larger. So the size doesn't have to stay the same, it just increases or decreases by some factor. Okay, so it says that what this postulate is actually telling us is that if you've got two triangles that are proven to be similar using angle-angle postulate, then all of the characteristics for two similar figures apply, even though we've only proven that two of the angles are congruent. So for example, on this figure here, we're using the diagram over here to the side. Okay, it says that angle A is congruent to angle F, and angle B is congruent to angle E. So we've got a pair of congruent angles here, as well as here and here, and therefore these two triangles are similar. So it says, what is the similarity ratio from ABC to FED? So we're going to put the 2 over the from. So we're going to FED from ABC. So whenever I set up my ratio, pick something from FED that matches up with ABC. So maybe we pick the only sides that have actual number values so that we can simplify. So I would choose my 2, which would be the 15, over the 25. And then we always want to simplify our similarity ratio if possible. So both of these are divisible by 5. This would simplify to 3 over 5. So it says because A and C are the first and last letters in the triangle, and the F and D are the first and last letters in the triangle, we can use their links to find the similarity ratio and the values for X and Y. So again, they reminded us we would do FD over AC since we're going to FED. So we would set it up exactly like we just stated above, 15 over 25, which simplified to 3 over 5. Okay, so then they want us to make a similarity statement and set up some ratios we could use to solve for the missing values x and y. So we already know that the two triangles are similar. We can actually copy down the similarity statement from above right here. Triangle ABC is what they said, so they switched these two letters, is going to be similar to triangle, so we need to switch these two letters, right? So we would say it's similar to triangle FDE. And as far as our ratios go, we can obviously see that they put the 25 on the top of the fraction, which means the side that corresponds with it goes in the box below it, which we already know to be 15. So remember, in a ratio, like we talked about in our last set of notes, can be rewritten multiple ways. So it's okay for them to flip it over. We just need to make sure we have it matching in the next ratio. So they had 25 over 15 equals something over 12. Well, the side that corresponds with 12 would be y, so I'm going to fill in that box with y. Okay. Same idea on this next one. We get that 25. We already know our 15 goes here. And I just come up here and check what side corresponds with 18, and that would be the x. So I must need to put x in the box. All right, so flip it over onto the back. We've got a few examples. We're supposed to determine whether the triangles are similar, and if we say they are, we're going to make a similarity statement, and the similarity postulate and the scale factor. If not, we have to write that they are not similar. Okay, so we're looking at number 3 here, or sorry, number 4. Looks like this is misnumbered. Change that to 4 through 8 there. Okay, so we've got that we have to prove that these are similar by finding their similarity ratio. So if we think that the two are similar, we could set up something from triangle ABC to match our triangle DEC over here, and we would just make a ratio using corresponding sides. Okay, so but before we can prove that they're similar, remember we've got to have the angle-angle similarity to prove that. So they already gave us one pair of angles here, and we know vertical angles are congruent, so we can add in another pair here. And we said that if you know you have two sets of congruent angles, then the third must also be congruent, and therefore your two triangles must be similar. So we can go ahead and say, yes, these are similar, and we can make our similarity statement. So triangle ABC is similar to triangle, so if I go ABC here, then I would go DEC on the top one to match. Okay, and then I just set up my ratio. Okay, so I could choose the side that's between the two angles, which would correspond with this one. So I could have 27 over 18, which would simplify to 3 over 2, or I could also flip that over and put 18 over 27, which would simplify to 2 over 3. Either one would work for our similarity ratio there, or scale factor. All right, number 5. Again, same idea. We got to prove we've got at least two congruent angles. So over here, we've got 48 and 90 on our first triangle. Well, I could add those up and subtract from 180 and figure out how many degrees this angle needs to be. So if I do that, I should get 42 degrees, which would then mean this angle and this angle are congruent, and I could do the exact same thing for this one to prove that it should be 48 degrees. So we do have 3 congruent angles, so yes, we know that these two triangles are similar. So we can go ahead and make a similarity statement. So triangle HFG is similar. So if we went HF, here we would go JK on the end. Alright, and now we just set up a ratio, picking some corresponding sides. So these two sides are obviously corresponding. I could set up 10 over 8, which would simplify to 5 over 4. Or you could also have that flipped over, 8 over 10, which would simplify to 4 over 5, since they did not specify which one we were going to and from. Alright, same idea here on number 6. We're going to have to prove that we've got some congruent angles, because right now the only congruent angle we have is the 35. Okay, so let's do that here in our first figure. If I add these two angles together, then I'm going to get 120. So I'd have 180 minus 120, which is 60 degrees. So this angle has to be 60 degrees, which does not match up what we have over here. I can do the same thing on this triangle, 180 minus the 2 that we were already given, which add up to 100, which leaves us with an 80-degree angle here. Therefore, we do not have two pairs of angles that are congruent. So these are not similar because only one angle is congruent, which was the 35-degree angle. Alright, number 7, we've got that these two angles here are marked to be congruent. And then in this bottom corner, we can see that they share this angle. Both of them have this angle. So if they share it, it must be congruent. And if we've got two pairs of congruent angles, we know that the third must also be congruent. Therefore, these are similar triangles. So yes, we have similar triangles. So we can go ahead and make the statement about which ones are, or which letters correspond in our similarity statement. So triangle HGJ is similar to triangle HFK. So I just set up corresponding sides. So we could say that our side here, 28, over the entire side, which would be 40, would simplify to 7 over 10. Okay, we also could have that flipped over, 40 over 28, which would simplify to 10 over 7. Alright, so on to the next example. Number 8. So in the top triangle, we can just add these two up, subtract from 180 to see if this third angle can help us out any. So if we do that, we end up getting that this angle must be 50 degrees by subtracting from 180. Okay, and then if we're looking at the entire triangle, this angle and the 85 would add up to 140, which would leave me with an angle of 40 degrees for this corner here. So we don't have two sets of similar or of congruent angles to say that these are similar, so these two triangles are not similar. Alright, last one. They gave us one set of congruent angles. We know we can go in and add that vertical angles are always congruent, so since we have those two sets, we can say that yes, these two triangles are similar. So I would then set up something so that I could solve for m. So we could pick our corresponding sides that we know to be similar. So 15 would correspond with 10. So I could set up a ratio of 15 over 10 and set that equal to m plus 5 over m and cross multiply and solve. So if we multiply this direction, we're going to get 15m, and if we multiply this direction, we'll have 10 times m plus 5, which we will have to distribute the 10 into the parentheses and end up with 10m plus 50 over here on that side. And then we would just solve the equation. So we would subtract 10m, which would leave us with 5m equals 50. Therefore, m must be 10. So since all we had to do was solve for m, we were able to do that. They did not ask for a similarity statement on this one. However, if you wanted to give one, you would need to name your vertices some points or letters so that you could make such a similarity statement as we did on some of the prior examples.